This is All Things Ansys, a podcast from the technical support staff at PADT. Episode 70, an update on what is new in Ansys Sherlock, and a quick review of the broader world of Ansys. Hey there, I'm Eric Miller, one of the owners at PADT, and your host for, now 70 episodes of this podcast. I want to thank you all for joining us on this audio journey that we've been on, and hope you've enjoyed it as much as we have. I also want to take a little bit of the time where I have been making sideways jokes / complaints about COVID-19 and 2020 or the Arizona heat, and heap some praise on PADT's employees. Some of you who listen to this podcast have worked with them. Many of you have not. I want to take some time to point out some things. We faced a lot of challenges this year, and through it all, they have not complained and pushed back. In fact, they do the opposite. They encourage each other to try harder. All things considered, PADT is doing just fine, and we owe it to all of them. So I want to ask all of you to join me in sending thankful thoughts their way. They've done an outstanding job across the board, and I just want to kind of put that out there in the ether. Now, let's talk about our interview. I'm a huge fan of one of Ansys's new acquisitions, Sherlock. You'll hear why in the interview. With 2020 R2 out, they've made it even better, making the modeling of electronics for thermal, stress, and vibe really much more powerful, much more accurate, and much faster. Now, I want to note, though, that our expert, Josh Stout, was having some landscaping done, and the leaf blower came through a bit louder than it sounded like when we were talking. We decided not to redo the discussion because, hey, it's 2020, and that is what happens when you're recording a podcast at home over the internet this year. So please enjoy our discussion on Sherlock 2020 R2. Well, I'd like to welcome everybody here to a Friday conversation with Josh Stout about Sherlock, one of the newer tools in the Ansys family, our electronics reliability tool. And we're very excited to really take a look at what's new in R2, 2020 R2. There's a lot of bad things that happened in 2020, but a lot of these enhancements that we're seeing in R2 are pretty good. So we'll focus on those. So welcome, Josh.
Thanks, Eric.
It's good to have you here, and you're just fresh off of doing a webinar on this topic, so I wanted to pick your brain about what's new. We've talked before about it, and I'm, of course, a big fan, as I was mentioning before we started recording, because I used to build very simplified versions of these models by hand using Excel and Fortran code and all sorts of crazy things, so I just love how this has improved. So, reliability is really not a maybe we should do it, or if we have time, but pretty quick these days. So looking at what's in R2, let's start off with, in case people don't know Sherlock, why don't you give me the 1,000-foot view of what Sherlock is?
Sure thing. So Sherlock is, as we've been talking about, it's a reliability tool focused towards electronics. So primarily PCBs with components on them. Might be located inside of a mechanical chassis, something like that. But really the PCB is the core. So Sherlock will read in an ECAD file that describes the PCB, board layout, layer thicknesses, material properties if they're available, component locations with part numbers associated with them, all of that information. And it will convert that into an MCAD model for you. So it keeps track of geometry of individual components based on its library definitions. It'll assign material definitions even if they're not already present. So it lets you control all of that and turn it into an MCAD model for mechanical and thermal analysis.
Nice.
Yeah. Nice. So using that information, of course, we simulate it, and then we bring that data back into Sherlock for post-processing from a reliability standpoint. So if we know all of the stresses and strains within our boards, we can make predictions for how long that will survive under various conditions.
So really far more than just, I focus on the model building part because that's such a powerful thing, but it's also being able to get that reliability data. That's what you really care about, right? Is these things, we turn our computers on and off and they cycle, and that's what's important. Exactly. Yeah. So what's your favorite enhancement at R2?
So favorite enhancement for me is it's going to be the export of reinforcement definitions. That lets us do much more detailed calculations than we could have before. So there were previously, I guess I would say, more simplified things that we could do for modeling the board. So we could either do a lump model approach where we average the material definitions for an entire layer of board, or maybe the entire board itself. And then there's the most extreme case where we explicitly model the individual traces and vias in the board. And of course, that's going to always be the most accurate, but it's extremely expensive and difficult to do, and honestly just out of reach for most users because it's so complicated. So the export of reinforcements is really an in-between step for all of these other methods. It's a small step down in accuracy from the full modeling approach, but it's still quite fast comparatively. So we basically have a background mesh that describes the baseline board material, and then we have a layer that we kind of print on top of it that represents the traces and the vias. So we can explicitly model those traces and vias using one-dimensional and two-dimensional elements in mechanical, but they don't directly impact the background mesh. So we can leave that relatively coarse, still good enough for the overall mechanical behavior, but we can capture the fine results around edges of vias, and, curves and traces, and specific material property distributions.
So it's kind of like, smearing is smearing, right? So you're smearing it, and then if you explicitly model everything, you've got to have a contiguous mesh, which is really heavyweight. So this is kind of the best of both worlds in that you've got a simplified representation of, say, a via, but it's contained within the mesh, and then tied to the integration points of I can't remember the integration points of the nodes through constraint equations, if I remember correctly. So.
Yes, I believe that's the case. I'm honestly not an expert on the numerics behind it, but I believe you pretty much hit it on the head there.
Yeah, something like that, right? So you kind of take the response and hook it all together with the equation. So it's pretty. I think it's wow. What a fantastic way to do it. Is it a fairly straightforward process? I mean, it's a matter of reading the ECAD and identifying what you want to turn into a trace or a via or something.
Yeah, it's really not bad at all. I would say it's less automated than the original process. But individual steps of it are. So if we're working within Sherlock, we can click on our model, and where we would normally say export to FEA, we have another option that is export traces.
Right.
So that brings up a new filter menu, so we can specify, okay, we only really care about traces with this certain total surface area, or maybe this width, things like that. It'll perform that filtering for us. It'll export that into a new file that can be read into SpaceClaim. So then when we do the full FEA export, that goes into a workbench geometry or maybe mechanical project, of course. We can add in this extra SpaceClaim file, and in that pre-processing stage, we then basically tell the mechanical solver that those traces are defined as reinforcements.
Reinforcements.
Yep.
Cool. Very cool.
So that's really the only change.
I like it. That's makes me want to try it. So, what was your other favorite thing in there that they added after the reinforcement capability?
So probably my next top feature is the ability to export to Ansys IcePack. For me, it's exciting to have this ability here. I think I'm more excited about where this will lead in the future than where it is right now. So I will mention that this export to Ansys IcePack, this is limited to classic IcePack right now, which I think is the main implementation. So I mainly work in electronic system IcePack as my presentation. But still being able to go from an ECAD file like this into a detailed geometric representation of a board for a full fluid analysis is quite convenient for a lot of ways. And of course, we can still couple this IcePack model with any of the other Ansys tools, like we would have to begin with if we started with an IcePack model.
Right.
So we can bring this into mechanical, for instance. So that workflow hasn't changed at all. It's just this extra step of being able to start with a complicated ECAD file. It's really, really nice.
Yeah, that really is. This is a question that shows my ignorance, but um, you can read an ECAD and build a model in Sherlock, but you can also do that in electronics desktop. Is that correct? And is there a significant difference or advantage of going one way or the other?
So that is true. You can do that from electronics desktop. The big benefit here is just in Sherlock's sheer power as a preprocessor, I
Okay.
would say. So it can utilize this huge library of components that already
Mm-hmm.
exists.
Mm-hmm.
So, for instance, if we have a surface-mounted component on a board, maybe we know a part number for it, we know what kind of package it's in. Sherlock has a library that tells us what that package actually looks like from a geometric
Ah,
standpoint. So we can define things like number of leads, how it's oriented on the pad, things like that that are really a hassle to try and model on your own. And that information is just not included in ECAD files.
right.
So yeah, so
Yeah.
Sherlock does that interpretation for you.
That was always my complaint is you get the ECAD file and it says part number, and here's the center of that part number. That's all you
Yeah,
know.
exactly.
Yeah. It's like that's not very helpful. So that's cool. So there's some advantages there, and hopefully we'll see that migrate over to electronics desktop, so we can save time that way as well. And then once you get your thermal results, you can do your mechanical stuff as well, which is great. Yeah,
Yeah, exactly.
nice. And then, if I remember correctly, there was a third thing that was new that was worth talking about, right?
Yeah, so they're continually improving the Workbench integration of Sherlock.
Hmm.
Of course, Sherlock is intimately tied with Workbench solutions. It has been since release, pretty much. It's all running with Ansys Mechanical, which we access through Workbench.
Hmm.
But they're improving that in this release, in that they're actually adding Sherlock modules or blocks. I
Hmm.
don't know what the standard nomenclature is for
Yeah.
Workbench these days, but there's an explicit Sherlock representation within Workbench now. So instead of having to start within Sherlock and then run the export FEA, then open up your Workbench and import it, we can do all of that within a Workbench environment. So we just
Oh,
add in the
nice.
Sherlock block, open the project from there, link it to our analysis of choice, and then add in a Sherlock post-processing block.
Hmm.
So that makes it a lot nicer for keeping track of like multiple PCB systems. For instance, we can have that all recorded in the same project file.
That is. So one form of integration that I think I would want is the ability to publish parameters out to Workbench and then manage them with the parameter manager in Workbench. Is that something that's there yet, or is that something we have to look for in the future?
Well, that's an excellent question. I don't think that's come up before, but
Hmm.
given that we have access to the mechanical solutions and the geometric definitions through
Hmm.
Workbench, I'm reasonably sure that would be doable.
Doable. Yeah.
Yeah, from the geometric side, it might be a little bit more tricky with these Sherlock blocks. But
Hmm.
if we're parameterizing the solution or some information about that, that
Hmm.
should be doable.
Doable. That's cool. That's exciting stuff. All right. Well, I mean that's three big things. I'm sure there's lots of little stuff under the hood, but three major enhancements, which shows that the Sherlock team's really working hard to make it a better tool. And I know that more and more users are using it, which is always a good driver for better capability. The more users we got, the more feedback, the more input, and the better the code gets. So look forward to doing that. So if people are interested in taking, if you haven't looked at Sherlock, I say this all the time. You really, if you work with any kind of printed circuit boards or electronics, mechanical reliability type simulation, definitely check it out. I think the other thing I'll mention is the Sherlock team's really good about writing blog articles. I don't know if you follow them, Josh, but it seems like almost every week they're putting something up, or every other week they're putting something up on the Ansys blog. So I always recommend people that are interested in it check out the Ansys blog because they talk about not just the tool, but electronics reliability, mechanical reliability, and vibration and thermal in general terms as well. So that's kind of a useful resource. Anything else you want to add before we take off?
I think we've pretty much covered it all. Of course, the recording from the webinar
Yes.
earlier this week should be available online, so there's more detail there, both
Mhm.
on background information and current state of Sherlock within the Ansys toolkit.
Yep.
So I guess shameless plug on my part. That's all I
Yep.
have.
Yeah. Yeah. Definitely. We definitely want people to check it out. And like we always say, we talk about it, but you got to see the picture. So hopefully, it's whetted people's appetite enough to get out there and take a look at it. And it does have the presentation does have a nice little kind of high-level look as well with pictures of what Sherlock does. And as always, if you have any questions, you can just give us a call, and Josh would be more than happy, or an email, to explain stuff. So appreciate your time on a Friday afternoon. I hope you have a good weekend, and we'll hopefully talk soon.
Yeah, of course. Thanks, Eric. You too.
Thank you. Okay, that was great. Hopefully you learned a little bit there, and it's whetted your appetite a little bit more to take a look at that tool if you need to use it. As always, please go to brighttalk.com and search for PADT to see all of our webinars. If you just want this one on Sherlock, search for Ansys space Sherlock. If you search for just Sherlock, we'd actually show up on top right now, but you're going to get a lot of other podcasts or recordings of webinars, actually, because as you can imagine, it's a common word to be used in other people's episodes. Even they're talking about Sherlock Holmes. So do that. Check that out. You can listen to the recording there. For today's commercial, I'm going to be really quick. Please reach out to us for your Ansys consulting, customization, and training needs. We're good at what we do, and we like to do it. What market you be asking for? So please consider PADT for those services. Let's take a look at the Ansys stock. So one of the things that doesn't suck in 2020 is the price of ANSS. Last week, Thursday, August 20th, it hit an all-time high of $328.92 a share. It started the year at $259.29, so that's a 26.28% gain since January 1st. As a reference, the S&P 500 is only, in the middle of a pandemic and economic slowdown, is only up 5% for the year. Just to feel bad about my poor investment decisions, over the past 5 years, the S&P 500 is up 76.82%. And to be honest, that's a pretty good indication of how most of my investments have done. I definitely am aligned with that index. Well, Ansys has done 261%. Dope. I really should have bought some Ansys 5 years ago. But then again, hindsight's always 2020 with stocks. Anyway, I got no Ansys news to report. They didn't put anything out there. And I do have some PADT news. We just announced, you may have seen the press release out there on LinkedIn and other social media, or our newsletter that we send out once a month. We're now adding Stratasys to the products we sell in Texas. So we're very excited to be growing in the Lone Star State. We've been doing Ansys there for several years now, and after seeing our success in the Four Corner region with their product and our success with Ansys in Texas, Stratasys asked us to grow. So if you're looking for 3D printers and you live in Texas, give us a call. We'd love to show you what we have to offer, and the same kind of expertise and good humor that approaches that we use to approach our Ansys customers is the same thing we do over on the Stratasys side. So do give us a call. So I'm going to do a rare thing. I don't think I've ever done it since I started listing articles I like in the Ansys blog. They really didn't have much. Maybe people are on vacation. So I'm going to actually skip that one. I don't actually see anything that I don't really think people should go click on and read at this point. But maybe next week we'll get a whole bunch. We didn't add anything to the Ansys or the PADT blog. Webinar-wise, our next webinar is on September 2nd. It's on structural optimization and additive improvements in Ansys 2020 R2. Always a very popular topic, and these are two areas that are really growing fast: optimization, especially topological optimization, and additive simulation of additive manufacturing. So always a popular one. It's going to be on Wednesday, September 2nd. We are having some issues right now with our website, so I'd normally say go to our event page and click there, but instead I'm going to send you straight to BrightTalk. So if you go to BrightTalk and search for PADT, you'll see everything we got coming up, and you can register right there directly in that interface rather than going to our website and then the BrightTalk website. The other PADT event that I should let you know about is our first virtual user group for our 3D printing customers. And many of you who listen to us about Ansys also work with us or care about 3D printing. So we'd love to invite you to that. It's called the PADT Virtual Additive Manufacturing Conference, or PVAMC. And that is September 14th, 15th, 16th, and 17th. It's basically going to be 2 hours in the afternoon. Each afternoon, we'll have a customer do a presentation about how they're using 3D printing in whatever area they're in. And then we're going to have a panel made up mostly of customers and experts from other areas to talk about the focus area that the customer talked about. The first day is manufacturing, the second is engineering, the third is design, and the fourth is healthcare. And you're welcome to attend any and all, however you see fit. We hope to see some of you there at that virtual event. We're really looking forward to that. To register, because of the website issues, I'm going to go ahead and send you to a shortened URL. Go to bit.ly/PVAMC. That's bit.ly.PVAMC. Paul, Victor, Albert, Mark, Charlie. We hope to see you there. That's all we have for events and really for the podcast. So I want to thank everybody again for joining us. Don't forget to subscribe at www.padtinc.com/opt-in. Spread the word. Don't hesitate to reach out and stay smart out there. We got a few more months to deal with all this stuff, and we like our listeners. Thanks. Thank you for joining us for the All Things Ansys podcast, episode 70. As a reminder, this podcast is not affiliated in any way with Ansys Inc., and the opinions expressed are those of the people on the show only and not of their current or former employers. For more information, visit www.padtinc.com/blog, and please share your thoughts and questions through an email to podcast@padtinc.com.